Alright, so we're going to do a couple of problems here. One is finding the equation of the ellipse and the coordinates of the foci given a graph. Um, the other class was graphing if we were given that information. And then our second problem is going to be to write the equation um, and graph it if we're given this information. So this is the harder one. We're going to start with the easier one. So for an equation, we need to have, we're not using these equations because it's centered at the origin. Our center is at the origin, so we're going to be using these equations. And also notice that it opens left and right, so that means the x squared term has to be positive. My bad. So we're not using this, we're using this equation. And we need a and b. And then this relationship tells us how to find c, which gives us the coordinates of the focus, or the foci, which are these here. They're c units away from the center. Alright, so let's check it out. This distance to our vertex, this distance is a. So this is a 4. And then the distance from the center to that other part of our box is b. And that is also 4. So we have an a equals 4, b equals 4. So now we're going to really just do, it's this equation, but now we have a 4 and a 4. So that's a 4 squared and a 4 squared. That pretty much is our whole equation. And then you plug your 4's in here and solve for c. So we have x squared over 4 squared is 16 minus y squared over 16 equals 1. There's our equation. And the foci are going to be along the x-axis. So it's going to be something 0 and something 0. And we know that c squared equals 4 squared plus 4 squared. For hyperbolas, this is a plus, notice, okay? This is a plus for hyperbolas. If it was an ellipse, this would be a minus. So this gives us c equals the square root of 16 plus 16. So c equals root 32, or 4 root 2 if you want to write it that way. So we have root 32 and negative root 32 are our foci. So that's our whole problem. 2 minutes, 2.5 minutes for that problem. Now, this is the doozy. Write each equation in graphing form for the hyperbola. Alright, so here are our foci. Those are they're vertical, my bad. So it's at 0, 5, and 0, negative 5. Those are the foci, so the vertices are somewhere in between those. So if we look at this picture here, these are the foci. That distance is c. This distance is a. So, and we also know that this relationship is true. Starting at one focus, picking any point along your graph, and then going to the other focus, when I subtract these two, it always equals a number. And in this case, it equals an 8. That's what we mean by the difference of the focal radii is 8. So we want to get an equation that involves that 8 that will, and then c is the distance from the center to the vertex. So they tell us, we know that here, from the center to the vertex is 5. Alright, why isn't this working here? Alright, so we know this is 5, and we know this is a and a. So from here, we're going to use, instead of some random point, we're going to pick a point right there. So from here to there is, well, first what we want to do is look at what this distance is here. This distance here is c minus a. So that makes this distance also c minus a. So from this vertex, or this focus, all the way to here, that's our D1, that's going to be a plus c minus a. And then we're going to subtract this distance here, minus c minus a. And that's all equal to 8 because the focal radii difference is 8. So that simplifies something minus itself, cancels out, so we have 2a equals 8. So a equals 4. So here our a is equal to 4 based on what I just did on the other page. We have our c. So we can find our b. We know that c squared equals a squared plus b squared for a hyperbola. It's plus. So it has 5 squared equals 4 squared plus b squared. And this is going slow for some reason. I don't know why. So we have 25 minus 16 equals b squared. So it's 9 equals b squared. So 3 equals b. So you didn't actually have to graph it. No, you didn't have to graph it, but I like to have a picture. So we know that this is going to have our kind of, whoa, my bad. This is going to be the, now this green, none of the green is actually part of our axis, or our, none of the green is actually part of our graph. The only part of our graph is this vertex, and then it opens up and down, so we're like this. So the red is actually the only thing that's the graph. The green asymptotes just help us see how slanty or non-slanty it is. Its eccentricity actually is the term for that. And we want to write the equation in graphing form. So it's centered at the origin, opens up, so it's a y squared minus an x squared over our distance here, a is 4, so that's a 4 squared, over our distance here, b is 3, that's a 3 squared, so that equals 1. So we have y squared minus x squared, this is over 16, this is over 9, equals 1, and that is it. So pause it, bounce back and forth between the slides if you need to, and that's how to do it.